This is Math 3 4.3 homework notes. That's Math 3 Unit 4 Lesson 3 homework notes, which means we're doing notes off of the worksheet 3. Alright, we're going to start with number 2. And what we're going to do is combine. Perform the indicated operation, write your final answer in simplest form, meaning we reduce if we can. Alright, subtracting fractions. When adding and subtracting, you need a common denominator. Since it already is a common denominator, you can write them as one fraction. 7x squared y is a common denominator. And 26 minus 5, those are like terms, so you get 21 over 7x squared y. And because there's no plus or minus, you don't have to do any factoring, you can just reduce. 7 goes into itself once. 7 divides into 21 3 times. So you have 3 over x squared y. Okay, next one. You'll have to be careful with this one. This one also has a common denominator, but when you write it, see how I wrote this one, 26 minus 5? It's 3x minus 4 minus 6x plus 5. That has to go in parentheses. I didn't do it over here. I could have, I should have, but I didn't because it was only one term. When you're subtracting fractions and there's multiple terms on your second fraction, you have to put parentheses to remember to distribute that negative, because you're subtracting the whole fraction, not just the 6. You're subtracting the whole fraction. So I will have to distribute that negative. So 3x minus 4 minus 6x minus 5 over x plus 3. So 3x and negative 6x, that's negative 3x. Negative 4 and negative 5, that's negative 9 over x plus 3. And I'm still not done because now I have a GCF. Up here I have a GCF of negative 3. I'm going to move my work up at the top. I pull out a negative 3. And remember, when I pull a negative out, it changes my next sign. That's going to be plus 3. Negative 3 times x is negative 3x. Negative 3 times positive 9 is negative 9, so it works. Over x plus 3, I can reduce that whole chunk, and my final answer is negative 3. Alright, we'll do more of these in class. Okay, number 5 is the next one I want to do. Now, these two are not common denominators, but I'm hoping you recognize that they are opposites. Do you see that? 2x minus 6, 6 minus 2x. You're going to pull a negative 1 out. So you have 3x over 2x minus 6. That negative 1 changes that plus sign to a minus sign, and pulling the negative 1 out makes the negative 2x positive 2x, and the positive 6 a negative 6. And now they have a common denominator. When they are opposites, pull a negative out of, it doesn't matter which one, I always pick the second because I can just change that middle sign. If it were subtraction, it'd become addition. If it's addition, it becomes a subtraction. Like this one here, when I pull the negative out here in class, that minus is going to become plus. Alright, so now they're the same, and I have 3x minus, I don't need parentheses around the 9 because it's only one term, over 2x minus 6. And then I cannot reduce because they're joined together as a family, but I can factor. 3 comes out, leaving behind x minus 3. 2 comes out, 2 times x minus 3. So now I can reduce, leaving behind 3 halves. Alright, next one I'm going to do is number 7. Okay, now these guys again are opposite, so I'm going to rewrite it. 2x squared over x squared minus 9. I always pull the negative. It doesn't matter which one, but I like to pull it out of the second one because then I can change that sign. That minus becomes plus. Earlier the plus became minus. X plus 15 is going to stay, and 9 minus x squared becomes x squared minus 9. Okay, and then now they're a common denominator. I can write them as one fraction. 2x squared plus x plus 15 over x squared minus 9. And so then I factor to see if I can reduce. The top does not factor, so I'm going to leave it as 2x squared plus x plus 15. You can try and try. I could tell you right now that doesn't factor. X squared minus 9 is x plus 3, x minus 3. Nothing reduces, so that is it. All right, I am going to continue. Apologize for my dogs barking in the background. Next one I'm going to do is number 11. Again, I'll talk more about these in class. Okay, the reason I want to do number 11 is because it's tricky. They look like opposites, but they're not. They look like opposites, but they're not. X minus 2, 2 minus x. X minus 5, 5 minus x. 2x minus 6, 6 minus 2x. X minus 2, 2 minus x. Those are all opposites. X plus 2 and x minus 2 are not. So this leads us to a different kind of problem. How do I find a common denominator when it's written like this? I am going to rewrite the problem here so I have some room to multiply by my missing factors. Okay, my common denominator, since they have nothing in common, is going to be x plus 2 and x minus 2. Why is that? This is a whole family, and I can't break it apart, so I cannot say, oh, my common denominator is an x or a 2. They do not have an x or 2 in common because it's a big chunk. So, since they have nothing in common, my common denominator is both the x plus 2 and the x minus 2. And here is what I do. I say, okay, what do I multiply this by to make that denominator look like that? X minus 2. What do I multiply this by to get it, the x minus 2 to look like this? X plus 2. And once I do that, I can then write it as one fraction, because this is going to be x plus 2x minus 2, this is going to be x plus 2x minus 2, and I can write it as one fraction. So I have 3 times x minus 2 and negative 8 times x plus 2, all in one fraction. And I will be distributing the negative 8, not the positive 8, but the negative 8. So that gives me 3x minus 6 minus 8x minus 16 all over x plus 2, x minus 2. And now you combine like terms. Okay. Okay, so that gives me 3x and negative 8x is negative 5x. Negative 6 and negative 16 is negative 22 over x plus 2, x minus 2. I cannot take a GCF out of the top, so that looks like that's as far as I can go. That's my final answer. Okay. I'm going to do some from the next page as well. So flip on over to the next page. Okay, number 13. This is where it does kind of get a little confusing, so you want to make sure you're paying attention. Okay, so like before, you have to factor first. There's nothing in common right now, and remember this is a whole family, so I cannot break up little pieces and say, oh, they have an x squared in common. That's not how it works. So I have to factor first. So double bubble. If I were you, I'd hit pause, factor on your own, hit play, and see if you got it to work. For this one, I have x minus 2 and x plus 1. For this one, I have x plus 1 and x plus 1. And I want, and the 1 is going to stay at the top for each one, and I want them to have a common denominator. So here is how common denominators work. I'm going to flip over to the previous page really quick. Here, because they had nothing in common, so the common denominator was each of it, the x plus 2 and the x minus 2. Here, they do have and x plus 1 in common. So I know for sure x plus 1 is part of my common denominator. Okay, so that's how you find common denominators. You ask what they have in common. If they have nothing in common, then you take all of it all together. But in this case, they have an x plus 1 in common, so I'm going to cover, and I'm going to cover because I already wrote it down there. Now, do they have anything else in common? No, then you take whatever's left over. So you're going to take another x plus 1 and an x minus 2. I'll repeat how I found that. Okay, we look to see if they have anything in common. If they don't have anything in common, you take those two, and all four would be your common denominator. Okay, what do they have in common? X plus 1, I wrote it down there. Put it in green. X plus 1, and it doesn't matter which one. X plus 1, and I wrote it there. Okay, so I covered. What's left over? Do they have anything in common? No, so I take them both, the x plus 1 and the x minus 2. Okay, and then I go to the first fraction and I see what am I missing. I'm missing, on the first one, I have an x minus 1. I'm sorry, I have an x plus 1 and x minus 2, but I'm missing the extra x plus 1. Do you see that? I'm missing the extra. I have the x minus 2. I have one of the x plus 1s, but I'm missing the extra one. On this one, I already have the two x plus 1s, but I'm missing the x minus 2. So I multiply top and bottom by the x minus 2. So now I have 1 times x plus 1 plus 1 times x minus 2. There's no negative to distribute there, just the positive 1. X plus 1 plus x minus 2 all over x plus 1 squared, because there's two of them, and x minus 2. Okay, I'm going to combine my like terms. X and x are 2x. 1 and negative 2 is negative 1 over, that was kind of hard to read, but that's an x plus 1 squared because there's two of them. I apologize for all the background noise. X plus 1 quantity squared because there's two of them, and the x minus 2. There's no reducing, nothing reduces. That there is your final answer. All right, I am going to end with number 16, and then again we're going to work on the rest of them in class together. I'm going to just rewrite it. 1 plus 1 over y, x plus x over y. This is called a complex fraction. When working with a complex fraction, what you're going to do is clear it. And you're going to clear it by multiplying everything by the common denominator. Multiply everything by the common denominator. All right, everything. So what you're going to do is you're going to you're going to make everything a fraction. I should have said that first. Make everything a fraction. After you make everything a fraction, you look at all four fractions. In this case, there's four fractions. You look at all four fractions and you multiply by the common denominator. And my common denominator here is y. So I'm going to multiply this fraction by a y, this fraction by a y, this fraction by a y, and that. So I multiply everything by the common denominator. So y times 1 is y. This is going to reduce and leave behind just a 1 over y. X times y is xy. I don't have to put it over 1. Plus the y's reduce and it leaves behind an x. I'm not done yet, but once you do this step, you should end up with a simple fraction, not a complex fraction. Do you see that? We got rid of all the complexity by reducing everything. We'll do more of these in class, don't worry. I have y plus 1 over GCF is x. X times y is xy plus 1 because x times 1 is x. That's what I have left. That reduces, and I'm left with not x, but 1 over x. All right. Take pictures. of the front page and back page. We'll do more of these together in class, including this page here. This is still part of worksheet 3. We'll do this together as well. But take pictures of these two pages and turn it into Google Classroom. That is it for this lesson.